spell your name? How do you spell your name? How do you spell Emma? E-M-M-A. Very good. How do you spell Emma? E-M-M-A. And then how do you spell Samuel? E-M-M-A, Daddy. Perfect.
How do you spell Daddy?
E-M-M-A.
And how do you spell Mommy?
E-M-M-A.
Very good.
For Samuel.
If you're happy and you know it, then your face will surely show it. If you're happy and you know it, clap your hands. If you're happy and you know it, shout hooray, hooray! If you're happy and you know it, shout hooray, hooray! If you're happy and you know it, then your face will surely show it. If you're happy and you know it, shout hooray, hooray! Wow, yes, you love it.
Okay. Okay. This is not the right one. Where is it? This one. The one I had. There we go. Okay. So we did, a while back, we talked about piecewise functions, right? Yeah. So what is a piecewise linear function? This is a function that has a constant rate of change, but it has different constant rates over different intervals. Is this consistent with your understanding of a piecewise linear function? Okay. Okay, so can you just briefly talk about what you're seeing here? I'll give you a better, this is 1, 2, 3, 4, and 1, 2. So in light of piecewise linear functions, what could you conclude about this particular line here? So talk for a second at your tables. What do you observe about this particular graph? Okay, go.
Yeah, definitely.
The solution is 2 y equals 2x plus 1 between
Okay.
on the left.
Oh, it's like dragging. It's just hard to see with stuff.
Okay, so this is a linear graph, of course. Is it displaying constant rate of change? Is it displaying constant rate of change? Yes. Okay, so what is the value of the constant rate of change? Did you figure that out? Did you talk about that? You had a debate. Okay, well, what if I told you it goes through the point 1, 3? Would that help? It goes through the point 1, 3. So constant rate of change is? 3? 2. Okay, what does that mean? What does it mean if the constant rate of change is 2? Yeah, Michael?
The change in y is 2 times the change in x.
He wants the change in y is 2 times the change in x. Is that what that means? For what change in x? For any change in x. For any change in x that you pick, the corresponding change in y will be 2 times as much as that change in x. That's exactly what constant rate of change means. Well said. Okay? Here's a different way to show a constant rate of change of 2. Instead of on the y-axis being some quantity, some y value, now the axis is showing rate of change value. And so, does this show a constant rate of change of 2? Okay? So no matter over any interval that you pick, you have the same constant rate of change over any interval length delta x. It's always 2. It's constant at 2. And how do we see that in the other graph? Same constant rate of change. Delta y, the ratio of delta y, or the size of delta y relative to delta x is always 2. Okay, so there's just 2 different types of graphs to show a constant rate of change of 2. One is actually graphing that rate of change, and so since it's constant, it'll be that horizontal line. And the one on the right is showing it as the slope of the line, that the change in y is always 2 times the change in x. Okay, so here is a piecewise linear function because it has a different constant rate for a different interval. So your job then is to sketch the graph on the right. So given this rate function, what would the corresponding amount function be? Okay, go. It's your job to sketch it. Okay, make a sketch. I want to come around and see what you come up with. What amount function would have this rate of change function? That's not how we do that as well. Okay, that's it. Okay. Alright, now you track. Just get a sketch of this. Not that. What's the rate of change down there? Negative 1? What's the rate of change negative 1? Change of x. What's the change of x? Get a negative change in y. Rate of change doesn't depend on the y value. It depends on how much y changes for a change in x. So, is that the same or different rate of change? You're saying rate of change depends on the fact that y is negative or y is positive. No, rate of change is about the changes. It's about the relative size of the changes, not the y values themselves. You're saying that when y is negative, that changes the rate of change.
No.
It's like the.
Corresponding delta y. Here's delta x. Here's the corresponding delta y. We're asking how big is that?
Well, I guess like it's really
Like always, you're always going to be positive 1. Okay. Did you get it right?
Yeah.
Observations, comments? Tyler,
How do you know it goes to the point 0, 0?
how do you know it goes to the point 0, 0? Michael?
It doesn't, or it doesn't have to. It's kind of like a constant. It just has to. Isn't that like integrals where you put plus c at the end? So it could be anyway.
Talk about rate of change. Talk about rate of change.
Well, the rate of change would be the same no matter where you put it, right? So you could theoretically put like negative x plus 5 and x plus 5 on there.
Okay?
Because then you get the same rate of change everywhere.
So it's a v, but it could be anywhere.
Yes.
As long as it's centered on the y-axis.
Okay, so that's our consensus as a class, that it's kind of this V shape, as long as it's centered on the y-axis. Everyone agree?
Yeah.
Everybody? Anybody? What about that?
Yeah,
Yeah,
a V
it's
shape
still
centered on
has
the flag.
Okay? So it doesn't have to have these two don't have to have the same y-intercept. Okay? So all these are okay. Okay, but so so this is again, this is just reinforcing that there's two ways to show a rate of change. Now, given a rate of change, though, we see that there's could be many ways to show the amount function that's showing those constant rates. Okay, so what does this have to do with taxes? What's this have to do with taxes?
I never heard of those.
Okay.
Yeah.
All right, let's see. Let's see what this all has to do with taxes. Is a very nice example of this, what we're kind of talking about here with piecewise linear functions. So let's just first talk about how do you read this. So if you're single, which most of you are, I would assume. Suppose you make $26,625 and you're single. How much tax do you pay? How much tax do you pay?
How much do you make?
$26,625. Is it too small? Okay, oh,
That's much better.
come back. No. Oh, there we go. Okay. So those of you who can read it, it's understandable if you can't. It's in this interval here. So therefore, if you're single, you pay this much. Okay, so the question is, how is this amount of tax computed? Where does that amount of tax come from? What's the basis of these values of tax in the table? Anybody know? Tyler has an idea? Yeah.
Depending on your income bracket or where you're at, you'll pay a higher percent or a higher rate of
Okay.
taxes.
All right. So he's saying that someone who makes $23,000 may pay a lower percentage of their total income than the person up here making $26,000. Other comments?
It looks like for every like $50 more that you're like making, you pay either $7 or $8 more in tax.
Okay.
If you're single.
So in this part of the table, I'm showing the rate is maybe all the same as what you're saying. That for the equal increase, you get an equal increase in taxes.
Close. It might be like 7.5 if it's just
Okay.
rounded or something, but.
But maybe in a different part of the table, for a single person making $75,000, what Tyler said was that they may pay a higher percent.
Yes.
So now for $50 more, you may pay $12 more in tax or something like that. All right. Well, anyway, we're going to kind of dissect this. That's just to get us warmed up here. So here is what Tyler was saying. This is the tax rate function. Okay, so this is the tax rate function. So let's first, if this is a function, we want to understand what's the input and what's the output. So what is the input into this function? What is x? Okay, taxable income, right? Okay, and what is the output? What is the output?
No, that's the right. Yeah, just that's the right.
So the input is the taxable income.
Oh, that's
Okay,
yeah.
that's what x means. And what's the output?
Taxes on that.
Okay, so it's a percent? So how is it a rate of change? Is the output of this function, are these the 0.1, 0.15, 0.25? Are they rates of change? We got one yes. Zach, is that a no? Are they rates of change?
In this function, no.
No? Anybody else? Melissa, what do you think? Are these rates of change? 0.1, 0.15, 0.25?
No, I don't think it's a rate of change.
So Michael, you still holding that they are rates of change?
Yes.
Tell me why.
So I think this would be like on those previous graph pictures. This would be the left side one. So between x being 0 and 8,370, it would have like a straight line at 0.1.
But that's not why these are rates of change. So you're imagining a graph.
Yeah.
That's okay. That's okay if you're imagining a graph. But why are these numbers rates of change? How is it that they're rates of change? Can we make sense of these numbers as a rate of change?
For equal increases in your taxable income, which would be like the independent value.
Okay.
You're going up 0.1 up in y.
So he said for an increase in your taxable income, the amount that your tax due would go up is 0.1 of that.
Yeah.
So that would
Within that.
within that range. Yeah, Lee, what were you gonna say?
So yeah, I was gonna say pretty much the same thing, just within each interval, it is the rate at which a change in x will multiply by that to get the change in y.
Right. Yeah. So these are values that you multiply by whatever change in x you have, and it gives you the change in y. So, question. If you make 25,000, how much are you taxed? How much, or I'm not asking for an answer, I'm asking you to get your calculator out and do something. But how would you calculate your tax on 25,000? What do you think?
15%.
15% of 25,000.
Yeah.
Nods, lots of nods, lots of nods. Tyler.
But this function itself only outputs a number. It's not actually like if you put this times your original rate, yeah, that would show. But this is just outputting a number.
Right.
It's just outputting like 0.1.
Yeah.
And then 0.5, so I don't see how those are the constant rates.
I don't think this is describing the function. I think this is just
Also, like just 0.15 would be the constant rate that you would use in the other function.
Yeah, so what is the output of this function? This is not, well,
The output is just the percent.
as a decimal, right? So it's a percent. Percent of what?
It just percentage of the tax.
Percent of taxable income as a decimal. Is that a rate of change? 0.25. Is that a rate of change? Does it, given a change in X, your taxable income, is the corresponding change in your tax due 0.25 of that? Yeah, sure. Yeah. Okay, so these are constant rates of change. So back to my original question: if you make $25,000 in a year, how would you compute the tax on that according to this tax table? 15% of 25,000. Most people are thinking this 15%. Okay, so let's look at another function. Okay, so this is a rate of change function. It's constant rates, but it's piecewise, right? So it's a piecewise constant rate of change function. Input is a taxable income. Output is the tax rate. The tax rate. Okay, how about this one? So this is the tax function. What is the input into this? Same input value, taxable income. Output of this function. The amount of tax you'll pay on that. Okay, so now let's just look at this real close. So you said that if you pay $25,000, if you make $25,000, the tax that you owe will be 15% of $25,000. So I want you to confirm or deny that, according to the tax function, confirm or deny that the tax you pay on $25,000 is 15% of $25,000. And if you think something else, then revise your explanation. Go.
The bracket bigger. Oh, you're going down the piece. Yeah.
Yeah. Okay, so I think, did we all come to a place where it's the tax that you pay on $25,000 is not 15% of $25,000? So if it's not that, what is it? Somebody new. Lauren, you want to? So if it's not 15% of $25,000, then how much tax do you pay on $25,000 according to this function?
Well, you're being taxed 10% up until $8,375,
Okay.
and then you're being taxed 20 or 15% on that remaining value of whatever 25 minus that number.
Daniel, same?
Well, I was gonna say like the exact same thing.
Okay.
You have to pay the tax. You have to pay the 10% on the first 83.75, and then 15% on whatever you make over that.
Okay, so then my question is, see 11. Or is it? No, 115. No. So then, let's revise our meaning to the output of this. So based on what you just did, what does what is the 0.25? It's the rate of change. What rate of change is it? Zach?
It's the rate of change for the other function.
Okay.
So, but it's the rate of change for the other function in that interval from 34,000 to.
Okay, so on what amount of money? So if we're looking at this right here. So you put in, so we put in, say, $50,000 into this, and it spits out what output? 0.25. What does that 0.25 mean if the input is 50,000? The tax rate. The input is 50,000. The input is 50,000, and you're getting a corresponding output of 0.25. What does the 0.25 mean?
Regular rate change in X from there on until 82,000. It's going to be the change in Y is going to be a quarter of that.
Okay.
It's the amount of, or the percentage of tax you have to pay on the difference between 50,000 and 34,000.
Okay, so what you said is both true, but it's not really a precise definition of the output. Because what you're saying is if you put 50,000 in, it's also talking about numbers like 60,000 and 65,000, right? Or 40,000, or 40,000, 45,000. So, yeah.
Output's the highest tax bracket you're in.
Okay. So it's actually the rate you pay on the $50,000th that you make. So if 50,000 is the input, you're going to get 2.25 on the output. That's the percent or the portion of tax that you'll pay on the $50,000th that you make. Okay. All right. So input and output quantities. We talked about, all right, structure of this function. So what's the structure of the function? What's the form of each line? 30 seconds, go. What's the structure of this function? What's the form of each line?
It keeps going back to what is that called?
The rate is
The second line. So like 59% of that from the dollar amount of the second line. And then adding that to yeah, exactly. Like the first one adding this and then this tax.
I'm not asking you to explain the function. I'm asking you to tell me what's the form of each line. What's the form of that line? Does it look familiar? Okay, linear, but in what form? Do you remember? Remember we did this, right?
Yes.
Remember the painters? So this was what we came up with for, this is point slope, right? When we did the painter. You've got one, it's M. And then you guys, when you guys built your piecewise generator, right? This was very convenient to use the point slope form. So the point slope form in as a piecewise linear function, that's how taxes are computed. Okay. This is called a progressive tax. You pay a lower percent on the first certain amount of dollars that you make, and then once you reach the next threshold, you start paying a higher percentage on those dollars. Okay. And this is a perfect application of piecewise linear function using point slope form. Okay, so now you got some work to do. What's the meaning of each of these? So each of these expressions is a value. What's the meaning of the value you get from each of these expressions? And this is in line number 3, I think. Right? Go. What's the meaning of each of these expressions?
Yeah, so the amount of dollars tax is that percentage. Oh, that's the third line. Yeah, that's 0.25 is the 0.25 is the plus the rate. On the last So what is that equate to? That's you at your 34,000 tax.
It's the tax and tax.
What you're being taxed
But tax.
not just the, like what are the songs? Alright. So you make 34,000. That's your input. So tax evaluated
Okay.
Well, it has to be. It's just for
Okay, let's regroup and see how we did. So x minus 34,000. Molly, what is that expression? What's the value? What's that mean? X minus 34,000.
So that is the amount that you tax at the 25%.
The amount that is taxed at the 25% rate. That's what she said. What do you think? Agree? Okay, so another way to say it, the number of dollars earned above 34,000, or what she said, the number of dollars in the 25% tax bracket. Okay, what is 0.25? Daniel?
It's the tax rate for every dollar over 34,000.
Okay.
And that's
The tax rate for this bracket, which is as a rate of change, it's the relative size of your change in tax to your change in income. Okay? 0.25 times x minus 34,000. Chelsea, what will that compute? 0.25 times x minus 34,000.
That's the tax rate on top of your. On what's left after 34.
So I heard you say it's a tax rate. Is it a tax rate?
No, that's actually net. It's 25% of whatever you have over 34.
Okay, which would compute what? Carla, what is 0.25 times x minus 34,000?
That is the amount of taxes you pay. Your dollar amount is over 34,000.
Okay, yeah, pretty good. Yeah, Victoria, go ahead.
Well, I was gonna say it's the amount of taxes you pay on the 25% tax bracket.
Okay. Yep. Amount of tax owed on the dollars earned at the 25% rate. Okay. What is tax of 34,000? Yeah, keep going, Tori.
Oh, it's the total amount you'll be paying in taxes at 34,000.
At 34,000. So
Well, yeah, the previous bracket.
the previous.
Yeah, the 0.15 tax bracket. So like the total amount you've paid up until the 25%.
Right. Okay, so it's the total tax you.
I did. Oh.
The total tax you pay up to for the first 34,000. So then you put it all together, and what do you get? What do you get? So now we've got the amount of tax owed on dollars in the 25% rate, the total tax due on the first 34,000. So what's this last line then? Actually, the whole line, right? The whole third line. Tyler. this time?
The total tax due for X amount of dollars in the 25% bracket. So you earned X amount of dollars in the 25% bracket rate. And
Okay.
it's telling you the
Did
tax.
you earn X dollars in the 25% bracket rate?
No, but the X dollars minus the 34,000 from all the previous
Okay.
brackets.
So what is this final value? Is that
It's the total amount of tax you're paying
on?
on. What do you mean on?
On the number of, that's not right. That's not right. So, Michael.
On a taxable income between 34,000 and 82,400.
Okay, so yeah, so for earning X dollars, which in this case is in that bracket, but for earning X dollars, it's how much total tax you pay on all X dollars earned. Okay, because it's the amount that you pay in the current bracket plus everything you paid up to that bracket, right? Okay, quick. Find tax of 50,000. Find the value. How much tax do you owe on 50,000? Go. Quick.
$681.
You already got it? Okay. So we're gonna confirm Carla's answers. How much is it?
$8,681.25.
$8,600 something dollars. See if you confirm that. Everyone, work it out. So as you're punching, think about this, right? So keep these meanings in mind as you punch. So things should make sense instead of just being a mindless exercise.
That'll have to be I type in one number.
I don't know how to do it without using. That's what you have to take like this. And make it into
What did you say wrong? These proposed tax was
Somebody else get the 6,800 number?
16.
8,600.
Oh, 8,600
8,680 and 75 cents.
and 80. 8680 and 35 cents. 75.
That's tax bill.
8680 and 75 cents.
Eight six eight one point two five.
8681.25. Well, that's what you did? So you got a rounding error somewhere.
Wait, that's what you got?
8681.25.
8681.25. Everyone who's trying able to get it? Can we go on? Okay, so the text is small. So I have a series of questions here to help you make sense of what we're looking at here. Where in this animation can you see, so Sarah, this is Sarah's tax scenario. Where can you see her taxable income growing? Where can you see her taxable income growing? Sorry.
Just along the x-axis.
Okay, which x-axis?
On either graph that has taxable income on the bottom.
Either graph. Taxable income is, you see that growing as she's working days and weeks throughout the year. Her taxable income grows, and that's being shown emerging on the x-axis. Both graphs. What does the current value of her taxable income mean when that amount continually changes? So how can we make sense of saying the current value of her taxable income? What would that mean, the current value?
Any value?
Any value. Well, okay. So
At a certain point in time.
at a certain point in time. So this is any value right here. Is that the current value of our taxable income?
Not
No.
now.
So how? What's that?
Not anymore.
Not anymore. Not anymore. Right. So the current value means.
That line for the dot.
What's that?
It's like at the end of the line, or then if you stopped it, obviously.
No, that's the magic words. If you stopped it. So we have to, you kind of, in order to conceive of a current value, you have to pause time,
Yeah.
right? So you have to kind of like pause time, and then we can talk about what our current value is. In this case, what, like 51,000 right now, the way where I paused it. Okay, so that's what we'll mean by the current value of taxable income. It's continually growing, and then to think of a current value, then we say we pause it, and we can look at that current value, and then we could start it up again. We could pause it again. Where can you see the marginal tax rate for the current value of our taxable income? So where do you see the tax rates? What's that?
The y-axis of the left graph.
The y-axis of the left graph. What do you think? Agree?
It's the output of.
Go ahead, Daniel.
I was gonna say it said the current for the current value, so it would be like wherever the dot is on the left graph.
Okay, so that's different. So is it, oh shoot, is it the y-axis or is it where the dot is?
Where the dot is. It said the current tax rate. So it's for whatever time.
That said, where can you find the current, the marginal tax rate for the current value of our income? Is it at the dot or is it the y-axis?
It's the one million.
And where do you find that value? Y-axis. Okay. The dot, the point represents that value along with that current value of income. But to find the value of the marginal tax rate, it's on the y-axis. It's the y-axis. Okay. So, did anyone? What question did I just skip over there? I don't know either. What does a point on the right-hand graph represent and the left-hand graph? So, what does a point on the right-hand graph represent? Raymond.
The point shows her taxable income at that moment and how much is due at that moment.
Okay, he said the point shows the taxable income at that moment and the tax due at that moment. That's what the point shows. What do you think? On the right graph. Yeah, well said. A point on a graph represents two values taken simultaneously. In this case, taxable income taken with tax due. Okay, so what does a point on the left-hand graph represent? Chris? So this point right here. So there's a point. What does that point represent?
Marginal tax rate.
Represents the tax rate? Just the tax rate? Alex? What does that point on the left-hand graph represent?
It represents her marginal tax rate for a specific taxable income.
Right. It's those two values taken together, simultaneous values. It represents the tax rate for the current dollar earned, right? For the current dollar earned. Okay? Why does the left-hand graph jump discontinuously? Why does the left-hand graph jump discontinuously? Yeah, sure.
Showing the different tax rates for each interval of income.
Okay? So the different tax rates for each interval of income. So I come up to here, and it's like $83.75 on the $88,375 that I earn. I pay, I think, is it 0.25. And then, no, what was it?
No, you were on the first. You're on the second first one. You were
First interval
talking
is
about the
8,000.
first one.
What was that?
That's
That one's
34,000.
up to. No, that one's up to like. I think it's 34. Yeah.
34,000?
34,000.
So on the $34,000 that you make, you pay 0.15 in tax, and then the $34,000 first dollar that you make, you pay 0.25 amount on that dollar, you pay 0.25 in tax. So you make the next dollar, and suddenly you're paying at a higher rate. Okay. Just that dollar. Why does the right-hand graph change slope abruptly? So you see there's a little kink there, and here comes another little kink right there. So here we go. Why does the right-hand graph change slope abruptly?
Because the tax due increases at that point.
The tax due increases.
Yeah, because the tax rate increases, so you're going to pay more, so the tax due and that taxable income increases. That's how I see it.
Okay, so what do you think? Why is there an abrupt change in slope? Is it because the tax due is increasing? That's kind of you were working that kind of rationale up there. Tax due is increasing even when it's not. Even when there's not the abrupt change in slope.
More taxes?
So, Winona, why does the right-hand graph change slope abruptly? Winona. What about the constant rate of change on the left side makes an abrupt change in slope?
It's the rate of change between marginal tax rate and taxable.
The rate of change between marginal. It's just the rate of change. So why is there an abrupt change in slope? Daniel, we're good. You want to try again? Go ahead.
Because the tax rate changes.
Right. The tax rate jumps, so then we see that change in rate as an abrupt change in slope. Okay, so and this is really kind of the big finale here. So in what way does Sarah's tax due accumulate? And how is this reflected in the graphs? How does the tax due accumulate? Exponentially accumulates. Sort of. I sure hope you don't think it accumulates exponentially. It feels like it. It feels like it.
I wish my income would accumulate.
Okay, so. But how does the tax due accumulate? Does she work for 3 months and then all of a sudden owe a bunch of tax? And then work for 2 more months and then all of a sudden she's got a...
Every year, right?
For every dollar she makes, there's tax due.
Right, exactly. Every dollar, every little bit of taxable income has a corresponding amount of tax that's due. So taxes accumulate bit by bit by bit. Okay, so after $40,000, she'll earn one more dollar. Okay, and I can represent that as, how can I represent that earning that next dollar? Or 50 cents, let's say. After 40,000, she earns 50 more cents. How can I use the symbols to represent that change in X, delta X?
So the government doesn't just screw you over once a year, it's screwing you over continuously.
All the time, right? Okay, and so then when you make that next 50 cents, you just, for making that 50 cents, you just incurred a little change in tax or a little increase in your tax of whatever rate we're at here. What rate is this? 25? 25% of that change in X now is an increase in tax. So how can we, this is $58,000. How can we represent the tax due on $58,000? Now we have two ways to think about representing the tax due on $58,000. What is one or both of those ways so we can represent that? I know we're over. This is kind of the big phenomenon here. That's a big point.
What was the question again?
How can we represent this amount of tax due on 58,000? There's two ways to think about it. Yeah.
The height of that vertical line that hits the point.
Okay, so I think what you're thinking is just the output of the functions, all right? So the output of the function. I think this is the next slide. So as a total amount of tax, we can think of that. How can we think of it as a total amount of tax? It's the output of which function?
Right.
On the right, tax. We can also think about it as what? The accumulation of every amount of tax on every 50 cents that you made the whole year. So what does that look like? Change in tax on the first 50 cents plus the change in tax on the second 50 cents, whatever, blah, 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 plus. Okay? So two ways to think about how much money you owe on 58,000. It's either this amount that's calculated for your income of 58,000, or it's the sum, the accumulation of all the little bits of tax from January 1st until you earned your $58,000. Okay?
That'd be like the area underneath the graph on the left one.
I'll never get to 58,000.
So area has nothing to do with tax. But I know you've been trained to think that. Lee.
Did you take the area underneath each of the little lines to also calculate your tax?
Right, you've been trained to see that, but I want to change your thinking.
Yeah,